In this video, we'll go through the rules of naming carboxylic acids. So again, these are another class of carbonyl containing groups. And so your carbonyl group, the carbon-oxygen double bond. However, you can identify a carboxylic acid because attached to the carbon of the carbonyl, you have a hydroxyl, so that OH group. Then you have carbon atoms, chain of carbon, ring of carbon, aromatic, whatever it is, but you'll have that OH attached to the carbon of the carbonyl, which indicates the presence of the carboxylic acid. So in order for a carboxylic acid to be present, that carbonyl group will be at the end of a molecule. So it has to be the very first carbon, or you can look at it as the very last carbon. But either way, it'll be the very first carbon that you encounter going from left to right or right to left. And so when we go through the rules of naming, you have to identify your parent chain. The parent chain is still your longest continuous chain of carbon atoms, but it must include the carbon of the carbonyl. Since the carbonyl is located at the very end or beginning of the molecule, I would recommend starting at that point and then figuring out your longest continuous chain. So if we start at this carbon, if we go across, we have 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. So it doesn't matter which way you number. So I'll just go down this time just for change so that I'm not always going straight across. And so I have those 6 carbon atoms. So instead of hexane, as we would normally call it, because we have this this functional group present, we have to drop that E and change the ending. So in the case of carboxylic acids, the ending is changed to oic acid. So instead of hexane, it becomes hexanoic acid. From there, we have to identify substituents. So I have one branch sticking outside of that boxed area, meaning that I have one substituent. This remaining portion, that carbonyl with that OH, was actually accounted for with the oic acid. So hexanoic acid accounted for those 6 carbon atoms and the functional group. But I still have to account for this substituent. I have that one substituent which contains 2 carbon atoms, so therefore I have an ethyl group. From there, I have to indicate where that substituent is located. Now it's already known that the functional group is located at carbon 1. Because remember, we can number from left to right or right to left. And so this carbonyl is always at carbon number 1. From there, I'm simply numbering to indicate where any substituents are located, if they are present. And so because I have this one substituent present, based on my numbering, I can see that that ethyl group is located on carbon 4. So I've identified my parent chain, I've indicated and identified any substituents and where they're located. Now I can put it together. I only have this one substituent present, but if I had multiple substituents, again, they would be placed in alphabetical order. And so when I put the name of this molecule together, it turns out that this carboxylic acid represents 4-ethyl hexanoic acid. No number is needed in front of hexanoic because we already know that the functional group is at position 1. There's a space between the oic acid. So 4-ethyl hexanoic space acid. But let's say you were given the name of the molecule and instead you had to draw the structure. So let's say that you were asked to draw the structure of, we'll just say 3-ethyl 4-methyl pentanoic acid. So using the name, we can draw the structure. So the name tells us a lot about the molecule. That oic acid portion lets us know that we're dealing with a carboxylic acid. So it tells us which class of compounds we'll have. Pent lets us know that it has 5 carbon atoms. Methyl tells me that I have one substituent that contains 1 carbon that is branching from carbon 4. Ethyl tells me that I have one substituent that contains 2 carbon atoms that is branching from carbon 3. From there, I can put it all together. When drawing, what I would recommend to do, go ahead and draw the number of carbon atoms that you need. So in this case, for this parent chain, I need 5 carbon atoms. So as soon as I put the marker down, I'm on carbon 1, 2, 3, 4, 5. Some people like to see their carboxylic acid functional group at the very end. Some people like to see it at the very beginning. I go ahead and draw my 5 carbon atoms. I typically draw my functional group at the very end. So even though I called this carbon 5, that doesn't mean that it's truly carbon 5 because I haven't added anything yet. And so I have my 5 carbons because I know that my longest continuous chain of carbon atoms must contain 5 carbon atoms in a chain. From there, I need to add my functional group. So I'm going to make this carbon the carbon of my carbonyl. In order to make it a carboxylic acid, I need, in addition to that carbonyl, I need an OH group present. So because I chose to put my functional group at that end of the molecule, this now means that this will be carbon number 1, this will be carbon 2, this will be carbon 3, this will be carbon 4, this will be carbon 5. So even though when I was drawing, I said 1, 2, 3, 4, 5, once I put in my functional group, it now changes the numbering. So now my functional group needs the lowest number. So now this is carbon 1. And so right now I have pentanoic acid because I have those 5 carbon atoms, including that functional group. But I need to go back and add in those other substituents. So I need to add in the 3-ethyl. So if I go over to carbon 3 should be an ethyl group. Ethyl is 1 substituent, so 1 branch, but it has 2 carbon atoms. If I just leave it like that, I have methyl. I have to make sure I add a 2nd carbon to make it an ethyl. I'm going to erase that for a minute. What I've seen people do in the past, they do it like this. That does not represent ethyl. That represents 2 different substituents. Ethyl is 1 substituent. So draw that 1 bond from your parent chain. That's 1 substituent. But that 1 substituent contains 2 continuous carbon. So this is your ethyl group. I also need a methyl on carbon 4. So go over to carbon 4. I've indicated that's carbon 4. Go ahead and draw your methyl group. Methyl is 1 substituent that only has 1 carbon atom. So you have your methyl group. So if I erase these numbers just to minimize confusion, I now have the structure of 3-ethyl 4-methyl pentanoic acid.